given a grid, we need to find out all the farmlands. Now farmland is that piece of rectangle. They have already given that it is a rectangular piece. It is a rectangular piece. All those rectangular pieces we have to find out, and the main thing over here is in the return type we should send back this point, the start row column comma ends row column of that particular farmland. So over here for this rectangle, suppose it will be start would be 0, 0 and end is also 0, 0. Okay. The next for the second one, start would be 1, 1 but the end would be 2, 2, right? So that is what we need to return finally. Over here also it is again kind of a template DFS if we want to, but we just need to know that how many rows should I move forward till there is one, and how many columns do I go down till there is a row of ones, to make sure that it is a farmland, and then we can just move on to the next farmland. So now after I have, suppose when I went to this, I searched that this is a farmland, the next time I'll just start with all the other DFSs, right? Do I need a visited array? Not required. Over here the trick is that I will just check what is the top and what is the left of this one. If the top is this, I'm considering it as 0 only. Initially I'm keeping it as 0 and then checking if that value changes. Similarly for this one also, if we see, it is a 0, 0 top and left. So any cell with a top of 0 and a left of 0 means that it is a start of a new farmland or connected component. One main thing to note over here that it can be done by using DFS and BFS. We can just do it by using the row and column as 2 pointers to it and then checking where it is ending and then starting with the new pointers of I and j in that, right? Like doing the DFS only, kind of DFS, but just a little tweak in it. Next thing, why can we do this? Because we have mentioned that it is always a rectangle. This bit I have discussed that top and left is the clever approach that we are taking. Instead of maintaining a visited array, we'll just say that if there is a top and left to it, then we for sure know that it is a newer connected component. So, and this happens because they have already given that for each group it is a perfect rectangle. Perfect rectangle means that there cannot be one over here. Then this wouldn't have become a rectangle, right? There cannot be a one. So top and left works over here. We can go to the code part of it. If we see the code, global variables again, use as many, set those global variables, then do a start running a kind of a farmland DFS, but from where to start? To know that start part, I am maintaining top and left and then updating the top and lefts. First I am initializing it with zeros because I know that there might be a case where this top and left might not be even present, like it is outside the boundary. So for that cases I'm just considering that 0, 0 and then I'm just updating. So suppose if this was not the case and this was inside somewhere which actually has an top and left, then those values whatever are present will be updated using these two lines. After updating, I'm just checking if that land is actually 1, if that is a land, and if that is a land, I'll just start with a DFS or a 2-pointer approach to find out till where it can extend, till where it can extend, till where I and j can extend. When I found out this part, I can just return and then start from where I left over here. And then because this was already done in this part, So whenever I go to everything, right, none of these will have top and lefts as zeros. So this will not enter again for this particular component. And then we can just look at it, what it is replying us with. We just wanted this, we know about this, right, already. We just wanted this point, ing of that point. So to get that row and columns, we can just initialize a 4 sized vector array which will contain our particular answer, like 0, 0, 0, 0, right, was in the answer, and 1, 1, 2, 2 was the answer, right? So r of start, column start, r end, column end. So this part to have this is this, and then we first populate the first two, which is the starts, because we know. Then we find out what is the end. So I'll just go till the element, till the element is ones, I'll go, and again I'll go till the j's are ones. Over here I will know, over here my I is here and j is over here, like over here. So that is why I'm doing this I minus minus and j minus minus to get the correct I and j. I can maybe just not do this, right? But then whenever I'm checking for this, right, this will happen over here in this column, which I don't want it to happen. So that is why I'm doing this. I minus minus is present over here, and then j minus minus, even if you don't do it, is fine. Over here we can just write j minus 1. So this is how we will be solving, and then return this array. The same array is pushed back into our answer array, and then when we find out all the connected components, r start, column start, and then row and column ends, we have found our answer.